Hello world and welcome to my channel. I'm Thorsten. I have more than 20 years of experience in working in international enterprises on Linux projects. And today I wanted to say why I love Linux or what I think about the beauty of Linux. So when I talk about beauty, I do not mean the look of the desktop or the icons or so. That's interchangeable. You can get any icon to any distribution and to any operating system. I want to talk about the elegance of Linux, about the inner beauty, okay? And I do not only want to talk about that beauty, but I want to show it to you on screen right now. And the second reason why I love Linux is the design principles. For example, we have this design principle, everything is a file. Well, think about it. It's true. In a file, you want to read, you want to write, and you want to seek. Seek forward, seek backward. And exactly the same mechanisms you have on all other devices. For example, on a hard disk, you have the same operations that need to be performed. Then on a sound card, you also have the same write operation. On a sound card, you would typically not do a read operation, but a write operation to output sound, and you wouldn't seek, but still you can use it. And that means that you use the same kind of operations, no matter if you're talking about a file, a hard disk, a sound card, or even a keyboard. You read from a keyboard and with exactly the same methods like you would read from a file. And that also means that you have in your Linux system a directory that is called dev. Typically it's under /dev. And I can list it here. And there you see the different devices. For example, TTY stands for teletyper, so for your keyboard. And SDA stands for SCSI device 1, so your hard disk, and so on. And it used to be that you could just output, for example, a WAV file to a device that was your sound card. Now, some distributions have changed here and are using different sound services, but that's it. The idea is you can use everything just like a file. And this is something that I find super elegant. Reason number 3 is everything around piping. Okay, the piping concept comes from Unix, not directly from Linux, but basically that's the same stuff for all of these. Also, the openness and the everything as a file approach both come from certain Unix variants. Regarding piping, how beautiful would it be if you could use the output of one command as the input of another command? For example, I have one command here. There's the command ls. Okay. I now use a pipe, and by this, the output that you see here in the console will no longer be output to the console, but will be piped into the next command as an input. For example, there's one command that is wc. Word count. It just counts the words in the input that comes. So if you have wc minus l, it will output all the amount of lines that you send it. Okay, and you see it here. If you want to count the lines, they're exactly 132. I can even use my keyboard with that. Yeah? I say word count minus l, and I give it one line, another line, a third line. Then I give it an end of file, Control D, and it outputs 3 because I have input exactly 3 lines. And this goes further and further. For example, you can use the command grep to find files, to find search strings. Grep stands for grep for regular expressions and print. And if you say grep minus I, it is case insensitive. And now I could grep for all lines that contain the string video. And in this case, you will see it is one line. And I could even pipe this further and find out how many files do I have in my directory that contain the string video by using this command. So with the first command, I list all files. With the second command, I filter out all lines that contain video. And with the third command, I count these lines. So I have one file in it that contains the string video case insensitive. And yeah, that is something I just find absolutely elegant. The fourth reason why I love Linux is about all these string operations that are possible. Let's face it. Most of you will see Linux only over the command line, and there are some great possibilities for doing string substitution. For example, you have the command uname -m. -m, and it shows you the computer architecture that this system runs on. I made some videos on assembler and how there is an ARM architecture and an x86-64 architecture. Predominantly on newer MacBooks, you have the ARM architecture, and on other notebooks, you have Intel architecture, x86-64 as it is called, and it has 64 bits of register with, and in this video I explain what that means. However, you will mostly not see which processor architecture you have, unless you want to execute a binary and install some software on your computer. So this information can become useful, and you can not only show it, but you can also substitute it. For example, if you want to write something in a Linux script, your computer has the architecture, and then you make $ parenthesis open, and then you say uname -m, and then what you see here behind the $ and the $ itself, this will be substituted by the output of this command. So let's check it. Your computer has the architecture x86-64, and of course, if you do not do it right and you say your computer has the architecture uname -m, it says exactly this. Your computer has the architecture uname -m. What you want to do here is you want to execute this command and put its output here and at this place, and this is possible with this technique. Reason number 5 why I think Linux is great is just this, what blew me away when I understood why it is the case. So you can, under Linux, join two commands by the operator ampersand, like this. Echo and echo hello and echo world. So first it echoes hello, then it echoes world. But the cool thing about it is that the second command will only be executed if the first command was successful. How that? Under Linux, every command has a return code, and you can query that with the command echo $? And the last command did not fail. It succeeded. There was no error. If I want to simulate an error, I can just call the command false. The command false delivers the return code 1, while the command true delivers the return code 0. So that means that if you have a command that succeeds, it delivers the return code 0. So the AND operator, which is the double ampersand, the bitwise AND operator, it needs to have more information, because if the first command fails, then the AND operator can already say, okay, the result of the AND operation will be false, because with the AND operation, if you only have one false, then the end result will be false. If the first operation if the first operand from an AND operation is true, the second operand still needs to be evaluated. And this here shows exactly why it is from a binary logic absolutely consequent to use this operator to execute the second command only if the first one was successful. With the same logic, you can also explain how the pipe or the double pipe operator works. The double pipe operator executes the second command only if the first command was not successful. So this could be an error handling routine. This here does not execute world because echo hello succeeded and delivered the return code 0. And forgive me, but I just love this this logic plays that actually have real world usage, like error handling, like chaining commands where all commands need to succeed. Just love this. Okay, I hope you enjoyed this video, and if you did, then please let me know in the comments. I'm your Torsten. See you again, hopefully, in one of the next videos.